Hi students, let's see some important numericals on velocity time graph. So we have the first question here. The question says, figure below shows the velocity time graph of a car starting from rest. The graph has three parts, AB, BC and CD. So the car is starting from rest and it is traveling along, and we have to answer the various questions. So if we look carefully at the graph, the car is starting from A and it is going to B. That is, the car is accelerating from rest to B and from B to C. It is traveling with a uniform velocity, and then brakes are applied and the car is retarding and coming to rest here. Okay, now see what the questions they are asking. So the first question is, state how the distance traveled in any part of the graph is determined. So in case of velocity time graph, the distance traveled is determined by the area under the velocity time graph. So if we want to know the distance traveled from A to B or the displacement from A to B, we have to calculate the area in this part. That is the area being formed by triangle AB and T. Okay. So this area will give us the distance traveled from A to B. If we want to know the distance traveled from B to C, then we have to calculate the area of this rectangle. So this area will give us the distance traveled from B to C. And from the point C to D, the area will give us the distance traveled after the brakes are applied. That is, this is the distance traveled in negative acceleration, which is retardation also. So this area will give us the distance traveled after the brakes are applied. Okay. Now let's calculate the area. So the distance traveled in part BC and AB we have to calculate. So distance traveled in AB is the area of the triangle ABT, the first triangle which this area. So the area of this triangle will be half into base into height, this part. So base is from 0 to T and height is from 0 to V. So the area will be half into T into V, that is TV by 2 meters. Okay. Now for the part BC. Now see, for the part BC, this area we have to calculate. So this is a rectangle basically formed by TBC 2T. The length is basically 2T minus T, that is T, and the height is again V. So area of the rectangle will be length into breadth, that is T into V, that is TV meters. Now if you compare the distance travelled in part BC and AB, we see that the distance travelled in BC is greater than AC. Distance travelled in AB is half TV and distance travelled in AC is TV. So more distance is covered in BC. Now let's see the next question. Now they are asking which part of the graph shows motion with uniform velocity, acceleration and retardation. So in this case, AB shows uniform acceleration, BC shows uniform velocity and CD is showing uniform retardation. Okay, now see the next question they are asking, is the magnitude of acceleration higher or lower than retardation? Give a reason. So the magnitude of acceleration or retardation in a velocity time graph is given by the slope of the velocity time graph. So we need to find the slope for both the part. So we need to find the slope of AB and we need to find the slope of CD. So depending upon the slope, so this is basically negative slope and this is positive slope, and the nature of the slope will tell us which kind of motion the body is undergoing. So let's see, we have to calculate the magnitude of acceleration and the magnitude of retardation. Okay, so acceleration will be change in velocity by change in time. So for your AB, which is acceleration, for AB my change in velocity will be that is from 0 to V, and change in time is from 0 to T, that is T minus 0. So it is V by T. Now see the retardation part. So retardation part is CD. So CD is the retardation part. So again we have to find the change in velocity by the change in time. So now see the velocity is changing from, actually velocity is V here, so velocity is changing from V to 0 because it is coming to rest. So the change in velocity will be 0 minus V divided by, now see the change in time. So time is changing from 2t to 2.5 t. So change in time will be 2.5 t minus 2t. So this is basically negative V by 0.5 t. So this will become minus V into 2 by t. So the retardation part is negative V 2V by t. So we can write 2V by t. So see the part AB acceleration was V by t and the part CD the retardation is 2V by t. So the magnitude of the retardation is higher. The magnitude of retardation is twice of retardation is twice the magnitude of acceleration. So if you take the ratio of retardation by acceleration, we will get 2. So this is your answer. Okay, now let's see the next question. So next question says a ball moves on a smooth floor in a straight line with a uniform velocity of 10 meter per second for 6 seconds. Okay. At 6 seconds, the ball hits a wall and comes back along the same line to the starting point with same speed. Okay. Draw the velocity time graph and use it to find the total distance traveled by the ball and its displacement. Okay, so what is given? So given is velocity is 10 meter per second and the time taken is 6 seconds to hit the wall. Okay. So we have two cases here. So the case one is AB. When the ball is starting from the position A and it is hitting the wall at B. And the next part is A dash B dash. That is when the ball hits the wall and it returns back to its original position or the starting point. Now for AB, the ball is traveling at a uniform velocity of 10 meter per second. So it is uniform velocity of 10 meter per second. Time was 6 seconds. So we'll directly get the distance because it is a uniform velocity. So distance will be speed into time. That is 10 into 6. So 60 meters. Okay. So for A dash B dash, now the ball is moving back with the same speed. So distance traveled will be again 10 into 6, that is 60 meters, but in backward direction. Okay. So now if we see the displacement, so the displacement will be 60 meters and here the displacement will be minus 60 meters because it is coming back. It is traveling this way and this is traveling this way. Okay. Now if we draw the velocity time graph, so it will be something like this. This is the time in seconds. This is the velocity, meter per second. Now we know the ball is moving at 10 meter per second. So we'll mark 10 here. The ball is moving at 10 meter per second. You see the ball is moving at a velocity, uniform velocity of 10 meter per second for 6 seconds. It will be a straight line because it is a uniform velocity. Now after 6 seconds it hits the wall. So after hitting the ball moves in the backward direction and with the same speed. So now the velocity of the ball will become minus 10 meter per second. So suppose we'll take minus 10 here. So now the ball will start moving like this. So it is again moving for another 6 seconds. Suppose now this is 12 seconds here. So this is the movement of the ball, and after moving for 6 seconds it comes back to its original position at rest. Okay. So this becomes the AB part, and this becomes the B dash to A dash part. Okay. Now the distance traveled in AB part will be given by the area of this rectangle, because it is a velocity time graph. So the distance traveled will be given by the area of this rectangle. So this is, so what is the length? Length is, it has traveled for 6 seconds. So the length will be 6 seconds, and the breadth will be the velocity, that is 10 meter per second. So this becomes 60 meter is the distance traveled in the part AB. Now let us see the distance traveled in B dash A dash part. So in this case, again the ball is traveling backwards with the same speed, so it will come back to its initial position in the same time. So this distance traveled by the ball in this part, B dash A dash part, will be the area under this rectangle. So now the time taken is same, 6 seconds into, now the velocity is in the negative direction. So it will be minus 10 here. So this becomes minus 60 meters. So the total distance traveled is 60 plus 60, that is 120 meters. And the total displacement will be now displacement is a vector quantity, so we have to take care of the distance also. So the first part, it has traveled 60 meter in this direction, and the second part it has traveled 60 meter in this direction. So basically it will become 60 minus 60, so 0 meters. So now displacement is 0 meter as the ball is coming back to its initial position. So the distance is 120 meters and the displacement is 0 meters. So this is our answer, and this is the graph for the ball which is traveling from A, hitting the wall and coming back to position A again. So this is in the positive direction and this is in the negative direction. So total displacement is 0 and total distance traveled will be 120 meters. Understood? Okay. Okay students, so we'll end the session here. If you like this session, please share and subscribe. We'll be doing more such sessions on numericals. Hope you have understood the velocity time graph. So see you in the next session. Bye. Thank you.